we are going to do a small recap. Last time we talked about molecules being made of very small particles. I hope you remember that. And we talked about, I think we introduced a little bit of diffusion, isn't it? Remember what we talked about diffusion?
Yes.
What was it we talked about diffusion? You can tell us what you remember.
Diffusion is the process when a substance from a high concentration spreads to a low concentration region. Okay,
when molecules spread from regions of high concentration to regions of low concentration. And have we seen examples of that happening? In real life, can we cite more examples of that happening?
The aroma moving from the kitchen.
Aroma, food aromas, that's very good. Anything else?
Tea leaves in water.
Tea leaves in water.
The tea leaves in water, mixtures, and so on. Those are examples of small mixtures of molecules. Anything else?
Powdered milk in hot water.
Powdered milk in hot water. That is still mixtures. Anything else?
The perfumes.
Perfumes, very good. Perfumes, aromas of perfumes. Anything else?
Air fresheners.
Air fresheners. We are all talking about perfumes and odor. Anybody who can tell us anything about smoke, for example? Smoke, you burn rubbish. What happened to the smoke? Have you ever burnt rubbish at home or at school and you see white smoke?
Yes.
What happened to the white smoke?
The smoke spreads out in the environment.
It spreads out in the environment. Actually, sometimes you can even smell smoke, even if you are not seeing it. Is that okay? But we have seen that white formation of smoke rising from the fire upwards, isn't it?
Yes.
So the spreading of molecules from regions of high concentration to regions of low concentration. That is what we saw, or that's what we're talking about. Today we want to consider, because most of these things are demonstrating that actually matter is made up of very small particles, and these particles are in a state of random motion. They are all establishments of that, okay? That in actual sense, the molecules of matter can move from one form and so on. That enables mixtures to be formed and so many other things, okay? Okay, I think this class has increased. We have a total and many more are coming in. We want to try to look at something else that also demonstrates the movement of molecules, okay? It is a specific experiment referred to as Brownian motion. So I'm going to share this document and then we see. Okay. So do we see that subheading in blue?
Yes.
What is the heading?
Brownian motion.
Brownian motion. You know, the Wazungu have very funny names. That experiment was formed by a British scientist called Brown. For us here, when they name you Brown, you know local languages. Miss Brown, you have had such names, Have you in your localities? Have you had anybody called Brown?
No.
No. Okay. Okay. For us, we have very many Browns in our localities. But anyway, that is a by the way Brownian motion. Is that okay? And Brownian motion. Someone read for us what it tries to demonstrate. I'm selecting somebody. This time we are getting organized. Put up your arm, and then I see who is reading for us. All participants raise their arms. I'm selecting Amber Regina. That one was one there. Is not in class yet. Okay, these are the people who want to read. Lena, you are reading. Unmute and read.
Brownian motion is a continuous, irregular, in brackets, non-uniform, zigzag, or erratic motion exhibited by small particles immersed in a fluid. Such random motion of the particles is produced by the collisions they suffer with the molecules of the surrounding fluid.
Let
For
us first
example,
pause. Let us pause there. I don't want you to continue. I want us to understand what Brownian motion is. Is that okay? Brownian motion, can you read again?
Brownian motion is a continuous, irregular, in brackets, non-uniform, zigzag, erratic motion exhibited by small particles immersed in a fluid.
Okay, let us break down that statement and try to understand it. Out together? They have talked about something called motion. Can you tell me what motion is? When something is in motion, what do you understand by that? Is it in a specific place?
No.
What is it changing? What is it changing?
Its
Position.
It is changing its position. Is that okay? So it is not stationary. It is something that is changing its position. Out together? So particles are always changing position. They are moving. They are in a form of movement. Now that movement, read this next word, is the continuous. What is something that is continuous?
Doesn't stop.
It does not stop. We cannot stop that motion. Is that okay? It always goes on and on and on and on, and it is unstoppable. It has to happen. I hope we are together, people. So this motion is always continuous. It is unstoppable. It is something that has to happen all the time. And then this type of motion, which is continuous, is the next word. What does the next word talk about? The next word in that statement?
It's irregular.
Irregular. They have broken down the words that are trying to define that. Irregular. Irregular, it is
non-uniform.
Read those words. It is
Non-uniform.
It is
Zigzag.
zigzag, and it is
Erratic.
erratic. Some books will break down that definition of that motion using a single word. They'll use the word random. All together? Because you'll be reading some books and they'll tell you they'll be using a word random. That word random means something that is non-uniform. It does not have a particular direction. It is unstoppable. It is uncontrollable. Altogether, you cannot control that kind of motion. Are we together, people? Are we together?
Yes.
Okay.
Yes.
So if I ask you, what are the characteristics of the motion of the particles, these particles, what are the characteristics of this motion? Can you tell me what they are? The ones that are being selected to be used are well-chosen words to describe that kind of motion. All together? So let us break down that type of motion. It is number one, continuous. Number two,
Irregular.
irregular. All together? It is continuous and it is irregular. All together? And it is exhibited by what?
Small particles immersed
All
in a
particles immersed in a fluid.
To be immersed in a fluid. Is that okay?
Yes.
They must be immersed in a fluid. What is a fluid? When we talk about a fluid, let us understand what a fluid is. What are the states of matter that form a fluid?
Liquid is something that flows.
Solid and liquid.
A fluid is a solid.
It's
No, it's a
something that
liquid. It's only a liquid.
It is only a liquid state.
Teacher, but
Liquid state and
gases
gaseous
are
state.
fluid.
Fluids are gases and
Liquid.
liquids.
How?
Is that
I thought
okay?
a fluid was a liquid.
Teacher, how? Fluid is something that
How are
flows.
gases involved?
A fluid
Eh,
is something that flows.
A fluid is something that flows. You have had the answer. And how many states of matter flow?
Gases and liquids. That
Gases and liquids. So this motion is carried out when particles are located or immersed in a gas or a liquid. Is that okay, girls?
Yes, teacher.
So we must be very clear when we are describing Brownian motion. It is a continuous and irregular motion exhibited by small particles or molecules when they are immersed in a fluid or a gas. I hope that is very clear. I've broken down that statement. The moment you understand that statement, then you are going to be able to understand what this gentleman was carrying out, how I described his experiment. Is that okay? And why we call it Brownian motion. So we should not talk about this experiment taking place in a solid. It must be carried out by putting particles in a gas or a liquid. Is that clear?
Yes, teacher.
Yes.
Okay. Okay, our next statement, Georgie was reading for us. Read for us that such
random motion of the particles is produced by the collisions they suffer with the molecules of the surrounding fluid.
Okay, so what causes that motion? Can somebody tell me what causes Brownian motion? What is its cause?
collision. They suffer with the molecules of the surrounding fluid.
So can anybody tell me what exactly, break down that statement to give it meaning, better meaning?
Brownian motion is caused by...
Okay, what kind of collisions have you come across? The most common collisions we know. Let us talk about that word collision. When two objects collide, what do they mean?
They meet.
When cars collide. When cars get in an
accidents exhibit collision. Is that okay? So there must be two bodies that must meet, isn't it?
Yes.
Yes.
There must be two bodies that must meet or collide. Are we together? So these particles are one of the bodies. These molecules, are we together? They may be molecules of what? Give me some small molecules. Molecules of what?
Dust.
Molecules of dust. Is that okay? And they collide with what molecules?
I think the molecules of the broom.
They collide with molecules of what?
The broom.
Of air.
Yeah. Are they that small?
Yes.
Yes.
Let us break down. When we are talking about molecules, we said that molecules of different substances are different. Do you remember that statement?
Yes.
May you please repeat the statement?
Molecules of different particles or different substances are very different. I hope you remember those statements.
Yes.
Some molecules are bigger than others. The sizes of the molecules. Some molecules are bigger than others. Are we together? Just like people. There are some people who are big, there are some people who are small, but they're all people, isn't it?
Yes.
Okay. Suppose a bigger molecule collided with a smaller molecule. Who would suffer most?
A smaller
molecule.
How will you see that suffering? Suppose you pushed something that is smaller, which will suffer more bigger motion. A
The
big
small
molecule
molecule.
to a smaller one. Is that okay? So under normal circumstances, the small body suffers more than the bigger body, isn't it? So when these molecules, small molecules, collide with other relatively big molecules that they find in the atmosphere, they now suffer motion. Is that okay? And that motion is what we refer to as Brownian motion. Is that okay?
Yes.
So
Yes.
read that statement again and understand it.
Such random motion of particles is produced by the collision they suffer with molecules of the surrounding fluid.
Okay, so you place small particles in a fluid, then you are going to see that motion exhibited because these molecules are always in a state of random motion. They are colliding with each other because whenever there is motion, remember it is erratic, it is in any direction, it can happen anytime, there is no particular order, so there are collisions that are likely to exhibit. It is like you are in class and everybody is moving in whatever direction they want. I think collisions, you can imagine that situation when you're in a class and everybody is moving randomly. Collisions are likely to happen, isn't it?
Yes, excuse me, teacher.
Yes, please.
So is the statement phrased like this? I'm just trying that Brownian motion is caused by collision of particles of different sizes, of different, yes.
Is caused by particles. It is a result of particles, the molecules colliding with the molecules of the fluid in which they are immersed. Okay, I've given you this example. When you burn rubbish, smoke is produced. Is that okay?
Yes.
Now, when smoke is produced, it comes into the atmosphere. And what do we find in the atmosphere?
Air.
We find the air, isn't it? Now, when the smoke molecules collide with the air molecules we find in the atmosphere, I hear echoes, please. What happens? The two types of molecules
kind of
collide
disappears.
with each other, isn't it? Are we together? Are we getting the point?
Yes. Yes.
And if they collide, then that random motion is going to be produced, or Brownian effect will be observed. You will see the smoke darting around, not in a particular direction, much as it is rising, but it will be moving almost in all directions. Isn't it?
Yes, teacher.
Yes, teacher.
The next example they have given us, can you read that example?
For example, after sweeping your classroom, observe the motion of the dust particles using light coming in from one of the ventilators. Describe the motion of the dust particles.
Observe the motion.
So what can you describe? I want one person because there are very many readers. What have you observed about dust particles? After sweeping, not whatever.
After sweeping, the dust particles go into the air and they collide with the air around. And when the light is hitting it, you can see them like moving around.
Okay. Now you are describing what is happening. The question is observe the motion. Can you describe your observation? There is a difference between observing and describe and explaining what is happening. What do you observe about the dust particles?
They start moving around randomly.
They move in different directions.
They move in different directions. I think that's what we observe, isn't it?
Yes. Yes.
Okay. I'm going to select one participant so that she may talk. The others keep quiet. Let me see. I'm selecting. I don't see your arms raised. I want one participant to tell us what she observes, not to explain what happens. Okay? I don't see people's arms up. What is happening? Mr. Sada, do you see people's
Teacher, they are raised. The hands are raised, teacher.
Select for us somebody who has raised their arm. I see 8 people
The
now.
hands are there. I can. Okay, Ade, may you unmute?
Okay.
And answer, Yata.
The dust particles move in random chaotic patterns.
Okay, very good. You are using the right words. The gas particles are observed to move in chaotic or random motion. Is that okay?
Yes.
Where else do you observe those gas particles? You have a very good example in your books. Let me put it this way. Let me show it to you. Let me show you that example. Look at that diagram. You tell me what you are seeing in that diagram.
A dirt road.
Do you see that dusty?
Yes.
Yes, it is moving in all
On a dusty
directions.
road, does the dust just settle down?
No.
That's all the time.
So what do you observe about that dusty?
It first spreads out, then afterwards it settles.
It spreads out in all directions. Is that okay? So that behavior exhibited by the dust is what actually tries to also to explain Brownian motion. I hope you have looked at that diagram and it is familiar. Most of us in Uganda have ever moved on a dusty road. Okay? Yes. So they are asking you to describe, I hope you're together. Now, can somebody tell me the explanation? Can you explain that motion? The first one was observed. Now I'm looking for the explanation. What causes that type of behavior of the dust particles?
Okay, let's have Mr. Chakon, your hand is up. Maybe you can.
No, I just wanted to request Mr.
something
to make me host again. And then I was also just wanted.
Okay. Explain. I want someone to explain.
Lina, may you respond to Mr. Sanjove's Lina Jueji?
What causes the particles to move is the collision that occurs when they are mixed with the air particles.
So these dust particles collide with the heavier air molecules, causing them to move in a state of random motion. Is that okay?
Yes, teacher, I have a question.
Teacher.
Yes, please.
Okay, are the gas particles heavier than the dust particles?
That is the assumption. The gas particles, the air molecules are heavier than the smaller dust particles, and therefore they are colliding. The heavier molecules usually collide with a slightly less or lighter molecules and cause them to move around.
What if the molecules of the dust were heavier? Would they just settle, or would the same thing happen?
Is that what?
If the particles of the dust were heavier, would they settle, or they would still collide?
Yeah. Whatever, by the way, it doesn't matter. Even if you are heavy, but you are knocked by something, there is still some effect on you, the heavier body, isn't it?
Yeah.
Yes.
But not that much.
So that those are basically whenever molecules collide altogether. And remember that these are relatively very, very small particles. Much as we are saying they differ in size, they are still invisible to the naked eye. What we see, what we actually know is more of their effect.
Yeah.
Okay, so much as we are saying they are bigger, etc., don't expect them to be so big that you can see them. No, they are still small enough. They have very small forces, masses, and therefore, even if the collision is like very light, that random motion is likely to be observed, causing that kind of random motion of movement. And the things that we can see, like small particles, why we see smoke? Because smoke is colored. I think you know that smoke is whitish. Browny, dusty is, there is some kind of formation. Otherwise, this motion is occurring even right now. It is taking place. And I believe that you can feel wind You can feel wind, you cannot see wind. I think you know that.
Yeah.
Excuse me, teacher.
Yes, please.
Now, I had that student asking about when the particles have settled down. Because when they have settled down and they are maybe resting somewhere like on the floor, I think in that case, their mobility might be quite limited in that.
Yeah, their mobility, definitely when dust settles down, it doesn't move until it is blown by maybe a wind.
Exactly.
But you said particles.
Excuse me, teacher.
Yes, please.
Excuse me, teacher. So
Yes.
Brownian motion is caused by collision of the particles in the substance with the molecules of the surrounding fluid.
Yes.
Okay.
Yes.
Okay. Is that okay?
Yes.
Yes. Yes.
Okay. Very good.
Excuse me,
Now,
teacher.
yes, please.
Could Eunice repeat what she has said?
Can she repeat what she has said?
Yes, I can.
Yes, please repeat what you have said.
Brownian motion is caused by the collision of the particles of the substance with the molecules of the surrounding fluid.
Yes. So even you can read that statement, such random motion, or you can paraphrase and say Brownian motion of particles is caused by collisions of the particles with the surrounding molecules of the liquid in which those particles are immersed. A collision was a collision. You are saying this word, okay, we are not all English, but the word is basically read as collisions.
Not collide.
Collisions, I told you, this is like the best example I can give you about a collision is a car accident. You collide, bodies collide, but you can also be running when you are not very attentive, something has taken your attention, you can collide with an electric pole.
Hey.
Yeah. So maybe,
for example, for me, I was in a
There are many
market,
examples of collision.
Somebody's attention was elsewhere, he collided with somebody's tent, and you can imagine when you collide with a tent in the market.
You collide with
There are many examples of collision.
Now you have to apologize. Yeah, you have collided with somebody's stall because your attention was elsewhere. So you understand what a collision is, isn't it?
Yes, teacher.
Yeah.
Yes.
Have you ever collided with somebody's stall in the market?
Tool.
No.
Yeah, a whole stand.
You collided with a whole stand?
Yes.
Okay, and what happened?
Luckily, the thing that the items on it didn't pour. It was heavy. It didn't fall over. But I got hurt. And my sister laughed at me.
I think there was some pain, isn't it?
Yes, definitely. Because it was heavier than me.
So I hope you understand now what a collision is.
Teacher?
Yes?
There are many examples of collision. Like a slap, and then like a slap, and then there's also running. If you run with let's say if you run with a lot of energy, the way your foot is pressing down on the ground, it's also colliding.
Okay.
There's a lot.
Yeah, we can say those kind of meetings are like that, but collisions are very interesting. A slap is one of the best in collisions ever.
In Indian movies.
Okay.
And dramas.
Indian movies,
Okay, let us look at how Brownian motion can be carried out.
One Nyanza was an address her hand up. I don't know what she had to say. I don't know if she's the one who has been talking.
Okay, but please, people, let us, much as there are several, let me first emphasize something. Listen, much as there are several types of collisions altogether, we should not over-exaggerate them. Let us keep the fun out of the notes and stick to the notes so that the notes keep making meaning. Altogether, it is very, very crucial that we stay focused when we are talking about the notes, but those are different examples of collision that can take place. Basically, we're trying to emphasize that when two particles meet, there is a motion that can take place, and that motion we have referred to it as Brownian motion. Okay, somebody was asking, yes, sir?
Yes, as you wrap that up, like that student said, particularly involving particles of a fluid and another moving object or another moving particle, small particles in particular, really. We may not be looking at things like toy cars moving together and they collide. That one may not bring out the meaning of Brownian motion, but a fluid surely should be part of the game here.
And I think we have reminded them that fluids include gases and liquids, because these experiments are carried out using gases and liquids. By then, these particles, some of you can assist us out together.
Excuse me, teacher.
Yes, please.
Can you please bring an example where the fluid is a liquid?
Yes.
Let me give her.
That's what I want to talk about. Do you know pollen grains?
Yes. Yeah.
Do you have flowers around your home where you can get pollen grains?
Yes.
All together? If you get pollen grains, try to put them on the surface of water.
They'll float.
I think it is water, Mr. Chakoni, that we use, isn't it?
Yes, it's water.
Pollen grains, they should be really tiny, not these big ones, but they should be as tiny as possible. If possible, as small as dust. They may not bring out this very well. They are not the best really, but they exhibit that motion sometimes. If they are light enough, pollen grains are very easy to get from home. Then you place them in water and you observe that motion.
And the observation will be very clear if they even had a microscope and some light shone onto the light in a transparent container like a glass or something like that.
Yeah, you should use a transparent container. You get very fine pollen grains and then you put them on the surface of water. Then if you have anything that can magnify, for example, people have specs, maybe, I don't know whether specs will work, but see, you will observe those tiny movements. Is that okay? Are we okay?
Excuse
Something
me,
that you
teacher.
can actually do from home, yeah?
Excuse me, teacher. You can
Yes,
also
please.
get ink from a pen and then you put in water.
Okay, the problem with ink, it will overspread into the water and start going down. But this motion here, the particle grains don't sink into the water. They only dart around. They just move around in a zigzag motion, but without sinking. The problem, what I fear with ink is that it will sink. It will start mixing with the liquid. You understand what I mean? Yeah.
So excuse me, teacher.
Yes?
What you're saying is that Brownian motion in gases takes place on the surface, in liquids takes place on the surface.
No.
In liquids, what we are really interested in is the movement of the pollen grains. It is very random, it is zigzag.
It takes place on the surface.
Yes, mostly it takes place on the surface without the pollen grains sinking. But the other thing that you could try is chalk dust, but chalk dust also has the same behavior. With the time it sinks. But this motion should be expressed mostly it should be taking place on the surface. But chalk dust can also exhibit that motion, especially if you use something like a petri dish. Do you know what a petri dish is?
Yes, that is in biology.
Remember that, and you look at, if you have anything that can magnify, you observe that motion being exhibited. Is that okay?
Excuse me, teacher.
Yeah?
Teacher, I was asking, can Brownian motion take place between like two fluids, like maybe a liquid and a liquid, like for the example of ink and water? Can it take place there?
It does. Actually, all these motions that we are talking about occur in, what do I call it? They are concurrent. The behavior is best exhibited by the experiments you are trying to describe. But there are so many things that can be taking place. While Brownian motion is taking place, diffusion could be taking place, dissolving could be taking place, and so many other things. However, here we are trying to break down one activity or one process from another, but all of them can happen at the same time. I don't know whether you get my point.
Yes.
So Brownian motion can occur between molecules of a liquid and a liquid. But the liquid and the liquid will not exhibit exactly what Brown is talking about. You understand?
Yes.
Because it will be like a mixture of activities. You are doing so many activities at the same time. But here, something can be best brought about by a specific experiment. I hope you get the idea. Are we clear, girls?
Yes.
Yes.
Okay. Yes, please. Somebody said, excuse me.
Excuse me, teacher. Yes, like when you're sweeping, is it the broom that causes the gas to collide with the dust to form the Brownian motion?
No. Sweeping, it only does this. There is already dust that is settled on the ground. Is that okay?
Yes.
So when you sweep, the dust particles, because they are small, they have the ability to rise up and mix with the air, the air that they find in the atmosphere. Am I making sense?
Yes, teacher. Yes.
So when they rise up, now the gas particle or the dust particles will start colliding with the air molecules that they find, and then that motion will be settled. But because gas molecules are heavy, usually that gas eventually settles back onto maybe windows and the floor itself, isn't it? But we can be able to observe that random motion exhibited by the dust particles when they are trying to be suspended in air. That's why I gave you the same thing, that when you are moving on a dust road, the car raises dust, isn't it? Then the dust starts moving around in a zigzag motion until because it is heavy, usually it is pulled down and it settles back down on the ground, isn't it?
Yes.
But that motion it displays when suspended in air is what referred to as Brownian motion.
Excuse me, teacher.
Yes, please.
I had a question. It's on the principle of the dust and the light. Why is it that when you're sweeping and there's light, the dust seems to be like it's climbing the light, like it's ascending upwards through the direction of the light, where the light is coming from?
Okay, let me first ask you something. Why do you think you have a light? What do you think is the purpose of light?
Generally, or in the principle of Brownian motion?
In the principle of Brownian motion and even generally.
I think the use of the light, since the light has particles in it, the dust particles collide with the light particles causing motion, random motion.
Okay. But let me put it this way. Suppose you went into a dark room. Do you need light?
Oh yeah, the light is for us to see the Brownian motion take place. Because in the dark room you can't see.
The light, the word that we shall use, and it is specific, is it illuminates. You are going to come across that word. It illuminates, it makes that more visible, brighter. Is that okay? For easier observation. Otherwise, those particles, whether they may be there, but you may not be able to see that motion until it is illuminated or it is lit up so that you can see it clearly. That is the purpose of your light.
Okay.
Okay?
Yes.
Okay. Are we ready to move on to the experiment itself?
Yes.
Yes.
Okay. Now I'm going to ask you, girls who are still interested. There was a time when we were 216. Now I see 208. Sebo?
There are some questions in the chat. Is Brownian motion caused by the collision of particles of a substance and the particles of a fluid?
Kati, whoever has asked that question, let us read.
Vivian Sandra.
Sandra, read. Read that statement which I'm highlighting. Such
random motion of particles is produced by the collisions they suffer with the molecules of a surrounding fluid.
So what is your question?
It has been answered.
It has been answered. Are you sure? Sandra, are you sure I've answered the question? I'm going to paraphrase my question and then I'll find whether it has been answered. Okay, let me try to answer you again. When I burn, I'll give you specifically the example of smoke. All together? Smoke particles when burnt. These are some of the things that happen. Remember that we are talking about density. So when you heat something, you increase its volume and therefore you decrease its density. So when you decrease the density, it has a tendency of rising up. Less dense air rises up, isn't it? So it is less dense, it has become lighter. Because of that lightness, it is immersed in air, the surrounding atmosphere. So it is meeting air molecules and it is colliding. Remember that all particles are moving randomly or erratically, so they collide. Now those collisions are becoming more visible, especially with something that is visible to the eye, something that has some kind of color. All together, that's why we can see the zigzag motion of the smoke. But there are smoke particles colliding with air molecules. I've talked about pollen grains. When you put very small particles, the water molecules are also in a state of random motion. The particles of pollen are also in a state of random motion. They are undergoing collisions, and that is the resulting motion is zigzag. Is that okay? So there should be two types of molecules that are colliding, and we observe that motion.
Mami Senjebe.
I
have a small video we could also add it to help reinforce that's what the point you're making. Is that possible?
Okay. It is very possible, but I think it will end our lesson almost. Okay, we can talk about that video.
Okay.
Mr. Chakone, I thought that they read this experiment and we are done with that before we go to the diffusion of gases, and then we end with that video.
Okay, no problem. That's okay.
I'm going to request one of you, Mr. Sally, select for us one person to read this experiment for us, and then we go and see that video, because I believe it will carry out that. Okay. 3 participants have already put their arms up.
Petra, not your gonna unmute and read.
Read quickly.
Brownian motion can be observed under a microscope. This is done by confining smoke in a smoke glass or glass cell, illuminating the cell with a powerful source of light, and then observing the smoke particles under a powerful microscope as shown in figure 3.8. The smoke particles are seen to move in all directions. Raising the temperature of the cell increases the speed of the random motion of the smoke particles.
Is that okay? So girls, this experiment here is carried out using a smoke cell. I hope you know what a cell is. I'll give you an example. A cell is usually a place of confinement. Most cells that we know are where criminals are confined. So this time we are not confining criminals, but we are confining smoke particles. Okay? Are we together?
Yeah.
Have we understood what a smoke cell is? It is a visible, it is a glass cell, because we are putting there smoke particles. Usually we put there a piece of cloth, something that is burning and producing smoke. I hope that is what you observe. Now, we use light to illuminate. What is the purpose of the light? To concentrate the light on the cell so that the movement of the particles becomes quite visible. Is that okay?
Yes.
So the observation is made through a microscope that magnifies that motion, because that motion becomes very difficult to see using the naked eye. So we need assistance of a microscope to make that motion visible. What is usually seen are very bright spots, or in other books they call them specks, moving around in a state of random motion. Okay, those bright specks which are observed, the reason why they are darting around or moving in all forms of directions is because the light smoke particles are colliding with the heavier air molecules, causing them to move in all directions. And that motion is referred to as random motion. So that is a simple experiment to demonstrate Brownian motion. I hope, Mr. Chakoni, that's what we are going to be displaying.
Yes, something, yes, but it's not about gases, it is Brownian motion in liquids.
In liquids, okay.
It is in liquids.
It will compound it, eh?
Yes.
Okay, so this is Brownian motion in gases.
Excuse me, teacher.
Yes, please. I'm listening. Somebody said, excuse me.
I think that will, I think
when
it
the
was Hosanna,
slide with, is there air in the...
What does what?
Slides with.
What does what? There is a word which I did not hear properly.
Have you heard?
No, I have not.
Yes, teacher, I am asking that when you put the smoke or a cloth that is burning in the smoke cell to produce smoke, what does that?
What's it? What's what? Network problems. Mr. Chakoni, we have less than 5 minutes.
Okay.
I think we'll display the video. We shall try to answer the questions. Maybe put it in the chat. Let you write it down. Mr. Sali will read it for us, and we shall be able to answer you. But we have 5 minutes in which to display a small video. Mr. Chakoni, you are going to be specific that you are demonstrating Brownian motion in the liquids, because this was in gases. I unshare. Do I have to unshare?
Yeah, I'm already there.
What's up, everybody? Welcome back to my laboratory, where safety is #1 priority. In this experiment, I'm going to demonstrate Brownian motion. Let's check it out. So I got here hot and cold water, and I got here ink. I got it from the pen and mix it a little bit with water. First, we're going to drop a couple drops of ink in the cold water and then hot water. So just a small drop. Well, it was a little bit more than 1 drop. As you can see, everything kind of stays together and sinking slowly down into the glass, kind of slowly. Now let's try the same thing in the hot water. Just a small drop. I put 3 drops. Let's see what happens. As you can see in this glass, it's actually kind of sink down really fast, and as you can see, it's actually dissolves before it's hitting the bottom of the glass. And in this glass, you still see a lot of ink all together, like lines, and this one pretty much all dissolved already. Why is that happening? Simply because water made of particles, and they always moving, and the harder particles are, the faster they move. Alright guys, that's pretty much it. Hope you enjoyed it.
I think that's it from this end. I think what it brings out is that the water particles are continually moving, hitting these ink particles, and you can see that in hot water, because the particles are moving faster, as we saw in the previous lesson, we do see the particles of ink quickly, moving around actually, and quickly disappearing. Yeah, somehow it brings out, I think, the point, because yeah, in liquids in particular. Thank you. I think you can continue and wrap up.
Okay, the girls are already running out. These girls can become 209, 201. I don't know what is happening.
190 already.
190 now.
Mm.
Okay, girls, we are wrapping up our lesson. We have been talking about Brownian motion. I think I'm only going to ask if there are questions, and then we move on.
Twin is hand up.
Abigail has raised her arm up.
And teacher, I was asking, can a gas and a fluid, can a gas and a liquid cause Brownian motion?
A gas and a liquid?
Yes.
Gas and liquid, Mr. Chakonyi. I think gas and that is not very much observable.
No, let us tell the child that in gases, you have gaseous particles always moving around. Yes. Now, how are you going to know that they are moving around? Brownian motion is really evidence for the motion of particles in a matter that we are talking about here, in fluids in particular. So gaseous particles are always moving around, and because they're moving around, the only way you're going to see them or to know that they are moving around is by using something else like a dust, as you put it. Yes. So the movement of the dust particles is happening because the air molecules are continually colliding or continually bombarding these dusty particles. The same thing happening in liquids. Liquid particles are always moving around. Those molecules are always moving around. Now, you may not know that they are moving around because they are not visible to a naked eye. So you get something that is bigger, that is visible, like a pollen grains, like a chlorophyll, like this ink we have just seen. And when you put it in that water or in that liquid, you see these particles you put moving around. Now, their motion is because of the motion of the molecules of the liquid. This is what we are referring to as Brownian motion.
Okay, so we have to use something that is visible according to the state of matter.
Exactly. Is
that okay? That's why I was talking about in gases we can see smokes. Why? Because smoke is visible. It is whitish in color. I hope you understand that.
Yes. So, Mr. Senjebe,
that kind of motion demonstrates that actually there is random motion. Yes, Sebo?
Exactly. Yes. So that child now we can say that it is going to be difficult for us to say that gas and liquids can show Brownian motion because the particles they are in each of these media cannot be seen. We need some other thing, either in a gas or in a liquid, to be able to demonstrate Brownian motion, but not a gas going into a liquid, because the particles of either are not visible to a naked eye.
Yes.
Yes.
Thank you so, Mr. Chakonyi. Charity?
Teacher, I want to ask about the experiment they showed where there was smoke in a smoke cell. So in that smoke cell, is there a gas that the smoke collides with?
Yes. In the smoke cell, a smoke cell is filled with air. So what has not been shown in that smoke cell will be because we say we trap smoke into the cell. How do you trap smoke? You get any burning cloth, then you allow smoke to enter that cell, then you close it up. So in that cell, you have smoke trapped with air. So you start observing that motion using a microscope. And in most cases, what you observe will be very bright specks of light moving around in random motion. Is that okay?
Yes.
Okay.
Yes. Yes.
Okay, okay, I hope we have answered that. Pearl, Chirabo? Chirabo, Pearl, unmute.
Does Brownian motion take place in a vacuum? Because a vacuum is a place without anything. So like in space, when you throw something, does it also exhibit the Brownian motion? In other words,
now,
does Brownian motion
let's break down your question, Pearl. You say what is a vacuum?
A place without
a vacuum is a space without anything.
Let's allow Chirabo to break down our question. People, let's respect Chirabo and she reasons herself. So Chirabo, a vacuum is an empty space, no particles. Now, what is Brownian motion?
Brownian motion is the continuous irregular motion exhibited by small particles immersed in a fluid.
Okay. Can Brownian motion take place in a vacuum?
Place without matter?
No.
Why?
Is that because there are no...
Listen to Chirabo. We are breaking down Chirabo's reasoning, please. Why can't Brownian motion take place in a vacuum?
Because a vacuum has no particles that will collide with the other particles that you throw in.
Is that Chirabo answering?
Yes.
So Chirabo, have you concluded?
No. Chirabo.
Then you did not understand your own question.
Teacher,
So ask the question again.
I understood the question. If does Brownian motion take place in a vacuum? Did you have understood that?
No particles. Where there are no particles, we have established there are no particles, isn't it?
Yes, but teacher,
can an accident take place in an empty road?
No.
That is as simple as that.
Yes, I have another question.
Chirab, have you understood that there is no Brownian motion in a vacuum?
Yes, I have understood.
Why?
Because the vacuum has no particles to collide with the other particles.
Exactly. So what is your next question?
Does Brownian motion take place in plasma?
Brownian motion, we have limited it to what? To what states of matter?
Gas and liquid.
Let's stop there. Is that okay? Let us not visit plasma. Let's leave plasma alone meanwhile.
But teacher, plasma has ions and the other things.
By the way, it does take place in plasma because remember, plasma is overheated gases. Is that okay?
Yes.
Extra or superheated gases. That's what plasma is. So Brownian motion can occur in that kind of, because we said fluids, isn't it? But for our own sake, let's forget about plasma. You understand what I mean? That for our own sake, let us slightly forget about plasma. When we get there, we shall get there. Are we okay?
Yes, thank you.
Okay. Musubika Thelma. Thelma, I'm giving you opportunity to talk. You are not talking. We are running out. We are 5 minutes out of whatever.
Yeah, I didn't want to say a question. I wanted to give the ending prayer.
You wanted to do what?
To give the